Hey everyone! One of the primary features of the video game module was video out. This allows us to connect our flipper to HDMI input devices. When the device was first released, I created video 106 on changing the color from orange and black to a custom color of your choice. Jay Blinked created a GitHub repository called VGM library that takes the graphics on the video game module to the next level. In this video, we'll look at some of the screensavers you can install, and we'll also look at how to create a game that leverages the multicolored video game module. Let's get started. Open lab.flipper.net. Make sure your Flipper Zero is plugged in. Click on Connect, and you should get connected to your Flipper Zero. Now that you're connected, click on the Apps tab, and then in the search box, search for the word Video. And then select the Video Game Module tool and click the Install button. You'll notice this is installed on the Tools folder, and this application allows us to update the firmware for our video game module. Next, we'll search for VGM, and then we'll select the VGM game remote. Go ahead and click Install. This application is installed in the GPIO folder. This application sends any Flipper Zero button presses to the video game module using the serial port. Next, we'll go ahead and click on Repository at the bottom of the page, and then click on VGM Library, which is the root of the project. You could clone this project using Get Tools, but instead I'll click on the Code dropdown and then do Download Zip. Once that's downloaded, I'll go ahead and click on the Show in Folder button. We want to open the folder where this zip file was downloaded. Go ahead and right-click on the file and then choose Extract All in the menu. Choose any destination folder and then click Extract. Once that's extracted, we'll go into the VGM library main folder, and then we'll start by going into the screensavers folder. In your web browser, make sure lab.flipper.net is not running. And then go ahead and open QFlipper. Open the File Manager tab, SD card, right-click on an open area, say New Folder, and type in VGM. Go ahead and open that VGM folder, and then drag and drop all of the UF2 files from screensavers into that new folder. If you get an error about files being too large, just go ahead and click Upload anyway. While that's copying, I'll go ahead and go up one folder and then go into the engine and then the Arduino folder. These are all the games ported by Jay Blanked that use the video game module engine. These games run in the video game module itself, and they use your Flipper Zero for the D-pad input. Next, we'll go ahead and right-click and say New Folder, and we'll type in Engine. We'll go into the Engine folder, and then we'll copy all the UF2 files for the VGM engine games. And again, click Upload if you get an error about the files being too large. The final step we'll do is we'll right-click on VGM game engine and say Compress to zip file. And we'll just name it VGM game engine.zip. You'll use this zip file if you want to create your own games. All right, make sure your video game module is connected to your Flipper Zero. Then go to Apps, and then Tools, and then Video Game Module Tool. And then next we'll choose Install Firmware from File. We'll go to that VGM folder we created. And here's all of the different files that we copied. We'll do the DVI logo bounce. Go ahead and click that right arrow to install. And this is updating the firmware in the video game module so that instead of the video game module replicating what's on our Flipper Zero screen, it's going to run the DVI logo bounce. There it is. Go ahead and click OK. And then we'll switch over to our TV connected to that video out. And there's that logo being animated by our video game module. For all these screensavers, we're just using our Flipper Zero to flash the firmware and to power the video game module. Install firmware from File, go to that VGM folder, and this time we'll choose Boing Ball. So Boing Ball is a little bit more advanced. Go ahead and say install. And this image is actually using 6 colors and 1 animated sprite. So that ball is an animated sprite. And what's happening is as it's moving across the screen, it's changing the color palette, and that's making this effect that looks like a rotation. Next, we'll install the Flying Toasters screensaver. And this screensaver has 12 animated sprites. Each sprite has 16 colors, and it's 64 by 64 pixels. And those colors are using an RGB 565. So 5 bits represent the red, 6 bits represent the green, and 5 bits represent the blue amount of color. So that fits in 2 bytes worth of data. Next, we have the Trippy TV host that we'll go ahead and install. So this looks like a flashback to the 80s, but I'm not sure who that host is. So in this one, we're using 256 colors, and we have 16 frames we're bouncing around between. Next, we've got our bouncing balls demo. And this one is animating 100 circles, each with a different random color. And our final screensaver is called Aquarium. And this one's probably my favorite screensaver. So at any one time, we're showing 12 animated sprites. Each sprite has a left and a right version and an A and a B that it's switching between to make that animated motion. Most of those sprites are 64 by 64, except for the bubbles are a little bit shorter. And they're all using 128 color palette. I think this is a great example of how the video game module is able to output a lot more than a single orange and black image. From the engine folder, we'll go ahead and install Flappy Bird VGM engine. And this time when it's done, we'll go ahead and say OK, and then we'll click back, and then we'll go down to GPIO, and then we'll do VGM game remote. And then once we're in there, we'll go ahead and click on run. So now any input on the Flipper Zero will be sent to the video game module over that serial port. So our Flipper Zero is just a remote. It doesn't display anything. However, the video out on our video game module is in color. So this is a little more fun than just playing that orange and black game. The current version of the VGM engine doesn't support HDMI audio, so there's no sound. But there are a few projects out there that use the Raspberry Pi and do HDMI audio, so hopefully that'll be a feature in the future. If you want to make your own games, head over to arduino.cc, click on Software, and then on Download Options, I usually do Windows MSI Installer. And then once it's done downloading, go ahead and run that installer. So now inside the Arduino IDE, go ahead and click on File and then Preferences. In additional board manager URLs, go ahead and paste in this URL. I'll leave it in the comment and in the video description. And then I turn on verbose output for both compile and upload. And with all that set, go ahead and say OK to the dialog. That'll download our board manager info. And then on the left side, you'll see the board manager icon. Click on that. And then we'll search for RP2040. And you should see a Raspberry Pi Pico RP2040. In my case, it's already installed. And I'm on the latest version, which is 4.4.4. I'm not going to hit remove and install, but you would just click the install button here. Next, on the top, choose Sketch, and then choose Include Library, and then Add Zip Library. Navigate to where you created that zip file at the beginning, and again, that's under Engine and Arduino, and it should be called VGM Game Engine.zip. Go ahead and click on Open, and that will install the library into your Arduino. Next, click on Sketch and Include Library, and then Manage Libraries. And this time we're going to search for Pico DVI and go ahead and say install on the latest version and then say install all to install all the dependencies as well. Pico DVI is where those screensavers were from, and it's also the dependency for a video game engine. Now that that's installed, go to File and Examples, and then down near the bottom, you'll see VGM Game Engine and all of the different game engine examples. You should look through each one of those examples. And then also under Pico DVI Adafruit Fork, you'll see the screensavers that had those screensavers we looked at earlier. You may need to change some of the settings to work with the video game module. For now, I'll open that video game module example. And this is just a simple example that moves a player around the screen. At the top, you can see in the comments some important information about the board manager, flash size, and CPU speed we need to set. And we'll be using that information later. Again, the concepts are similar to the game engine I covered last month. The player update method changes the position of the player. It handles different game input values, changing the Y and X position of the player. Rather than call position set with new position and then old position, I'll create an else block and move that code into the else block. So this way we'll only set a new position if it's changed. And the rest of this method is about setting the camera, but since our level is the same size as our screen, this effectively is a no-op. Player render renders any information after the sprite is drawn associated with the player. Next, we have the Arduino setup function, which is our main program. We call setupfs, which sets up our file system. And then we create a new game object, passing in a vector of 320 by 240. That's the size of our screen. We don't have any start or stop callbacks. Our foreground color is red and our background color is white. Our flipper 0 sends input via the button UART library, and so we go ahead and add that as an input source. This example just has one level with a 320 by 240 resolution. We add that level to our game, and then we define the data for one sprite, which is a 10 by 10 image. Later in the video, I'll show you how to convert a PNG file into your own sprite, and we can use any dimensions we'd like. We create our entity, setting its initial position to 160 by 120, which is the center of the screen. The size of our sprite is 10 by 10, and we set that initial sprite. We don't have separate left and right sprites. We don't have an initialization or destruction. We set our update and render callback that we just looked at, and we don't have a collision for when this entity intersects another entity. We add our entity to the level, and typically a level would have more than one entity. This is just a simple example. And then we create our game engine with a target frames per second of 30. And then we call engine run to run the game. And then our loop method is just empty since everything happened in setup.
So now let's look at creating our own entity sprites. We'll start by bringing up a web browser to flipsocial.net/png to FB. And then we'll go ahead and choose a file. And this lets you pick any PNG you have on your computer. I'll go ahead and pick this image that my wife made. And then we'll click upload. This will give you the data to put it in a frame buffer.
It will also give you the C++ code for the RGB565 array, which is what we need to use in our sprites.
Go ahead and click copy code, and then we'll say OK. Okay, I'll go right before setup, and we'll go ahead and paste in that new code. And I'll call this player sprite 42 by 42 pixels. And we no longer need this 10 by 10. I'll go ahead and delete that. And then instead of player 10 by 10, we're going to want 4242. We need to cast this to a uint 8t pointer. And then we need to change the size of our image to 42 and 42.
So we'll go to Tools and then Board, and then we'll choose the Raspberry Pi Pico, and then on the list we'll choose the Raspberry Pi Pico as the option. So this should say Raspberry Pi Pico. And then under flash size, we'll choose the one that has FS64 KB, just like what's shown in the comments. And the last thing is the CPU. Instead of 133 megahertz, we need to switch it to 200 megahertz overclock. And that's it. Go ahead and choose Sketch and then Export Compiled Binary. That'll take a minute or two the first time you run it, and you may get some warnings which can be safely ignored. Hopefully you'll get a done compiling message. And if you look up a few lines, you'll see a path to where your output was stored, this ELF file. When you navigate here, you'll need to use single slashes instead of double slashes. In that same folder, you'll find a UF2 file. You can go ahead and drag that UF2 file into our engine file on our Flipper Zero. You can see we now have an example.ino.uf2 file. And then we'll go ahead and flash that firmware to our video game module. So go down to Tools, Video Game Module Tool, Install Firmware from File, VGM, Engine, and then you should see example.ino. Go ahead and say Install. And then once it's installed, we can say OK, and then go ahead and click back, and then go into GPIO, and then go into our video game module game remote and click on Run. And now we can use our Flipper Zero to move the sprite around the screen. Please like and subscribe, and if you have any questions, leave a comment below or reach out to me on Discord.